Hi, good morning to everyone. I am Andrea Pisano. It doesn't work. Okay, I'm Andrea Pisano, researcher at CNR, the Italian National Research Council, and I'm going to present you some results and consideration based on the content of two recent publications. The first one is an analysis of the Mediterranean marine heatwave under current global warming, and the second, an analysis of a record-breaking persistent Mediterranean marine heatwave that started in 2022 and lasted until 2023. The definition, the first quantitative definition was given by Octay in 2016, and its state is that a marine heatwave is defined a prolonged and exceptionally ocean warm event in a given location exceeding the typical condition, where typical are defined upon a reference climatology. So, in practice, a marine heatwave detection is identified whenever an SST anomaly exceeds the 90th percentile for more than 5 consecutive days. And following of day, the climatology is defined as a fixed climatology on a at least 30-year long period. But perhaps we should go beyond this definition, and this is the topic of the first work, where I analyzed 41 years of Mediterranean SST data derived from the Copernicus Marine Service SST dataset, covering the period from 1982 to 2022. It is evident that the Mediterranean Sea is particularly sensitive to global warming, and now the trend has been estimated into about 0.4 degrees per decade, meaning that temperature increased of about 1.6 degrees in the last 4 decades. Now, by applying the update method with a fixed climatology to this time series, the result is that all the marine heatwave parameters, such as duration, coverage, frequency, and intensity, increase over time. And one of the most outstanding consequences is that during the last years, the Mediterranean Sea reaches a status of perpetual marine heatwaves. So, as these parameters really increasing over time? Well, the answer is in the trend and the definition of climatology. Indeed, the trend introduces a shift in the mean SST, as it is evident in this plot, where it is shown the annual cycle of Mediterranean SST from 1981 up to 2023, and the temperatures move towards higher values as time goes by. So in practice, by using a fixed climatology, the mean SST is somewhat frozen, so that the temperature records will move farther away at a certain point, will move away from their climatological values, even in the absence of extreme events. The trend makes the system non-stationary. This is the point. So in presence of a trend, how can we define a reference climatology? Well, for example, by removing the trend before applying the update method. By using this approach, the previous scenario is overcome, and now all the marine heat wave parameters are more stable over time. So the trending allows to separate long-term changes, such as trends, from the short and abrupt variation that are characteristic of these extreme events. And also the trending allows to define, to use a fixed climatology without overestimating marine heat waves at the end of the years. A similar study has been performed at global scale by Amaya et al. They proposed to use a shifting or revolving climatology with a window of plus minus 50 years, but they used SST from model data, so covering a period until 2100, and this is well evident how the SST time series in red at a certain time is always over the fixed climatology, while adapting the climatology, in this case using a shifting baseline, this issue is overcome. Moving to the second argument, a severe Mediterranean event started in May 2022 in the Mediterranean Sea. As you can see in this plot, we have in red the daily mean SST time series along with the baseline climatology in blue. So since May, a marine wave began, and in 6 days increased of about 1.6 degrees. This event persisted until March 2023, the time we were writing the paper, with maximum values between July and August, where anomalies reached 6 degrees in the Mediterranean Sea. Below there are the temperature anomalies, and the evident modulation are due to intense wind events, shown in the next slide. Here, in the same work, we assessed the role of wind-driven mixing into the propagation of the surface warming below the depth. We used in situ data collected at the Lampedusa oceanographic station. Lampedusa is an Italian island between Sicily and Tunisia. So we collected in situ temperature at 1, 2, 5, and 18 meters, as well as wind speed. And here, what is interesting to note is that after the beginning of the marine heat waves, the near surface temperature decoupled from the temperature at 18 meters. And at the first intense wind event, there was a cooling of the near surface temperature and an increase of temperature at 18 meters until the latter reached the same temperature values. After the intense wind event, the near surface temperature started increasing again, while the temperature at 18 meter remained practically unchanged until the next mixing event. This result tells that the propagation of the surface worm is mainly driven by wind-induced wind-driven mixing. Um, Very quickly, the Mediterranean marine heat wave of the last 2 years was concurrent to a strong anticyclonic condition over Central Europe that started in the boreal spring and lasted until the end of the year, with also characterized by weak winds conditions. This strong atmospheric heat wave also uh, induced a severe drought in the Central Europe. So the onset and evolution of this Mediterranean heat wave we found related to this atmospheric condition. What is happening since March 2023? Well, after a break between March and June, the marine heat wave started again since June, and it is still persisting. Values of about 30 degrees were reached this July, with anomalies more than 5 degrees. So in summary, uh, the message from my side is that we should pay attention when defining a baseline climatology to identify extreme events. Because the trend could make the system non-stationary. So to adapt the climatology in order to properly separate a long-term variation from an abrupt one. And then, for sure, we need to further study the role of atmospheric forcing and in general drivers for marine heat waves and their impacts into the ecosystems. So thanks.